Hi friends, today we can discuss about the function and its limits. Can be illustrated like this: y equals f of x, where x is the independent variable and y is the dependent variable. So here we have to discuss about the functional limits. What do you mean by limits? Limits means it's a value of the function very close to the actual value. Value of the function very close to the actual value. So we have two types of limits here. One is left hand limits and other one is right hand limits. What do you mean by left hand limits? Means it is coming functional left side, and another right hand limits means it is coming in right side. So actually if you have a function with the limits, means it should be equal, or if left hand limit is equal to right hand limit, this is called limit exists, or this function has limits. If this is not equals, function does not have a limit. For example, LHL not equal to RHL. This means, which implies function does not have limit, or does not exist. So we can express like this also: limit does not exist, DNE. If LHL equal to RHL, we can say that is limit exists, which implies limit exists. Then we will go to an example to evaluate the limits here. If another one more rule is there, LHL equal to left hand limit equal to RHL equal to the functional value, the value of the function. So this can be states that limit exists and the function is continuous. So these three rules we have to study in this lesson. Then we will go to an example for that. We can have a question, which is question number 1. F of x equals, it's a function, f of x equals, we have like this expression such that, which means we have two types of different domains. So which means x plus 1, which is if x less than 2, and next one is x square minus 4 if x is greater than or equal to 2. For this problem we have, as I told you before, we have two domain, which means x plus 1, f of x equal to x plus 1 for x less than. Like that, similarly for f of x equal to x square minus 4 if x greater than or equal to 2, which means we can consider this is for RHL. Why we are considering for that? In the number line, we know that is in the number line, if it is 2 is coming here, this is positive direction and it is going to right hand, and in the number line this is negative direction, it is going to left hand side. So that's what we are explaining like that. For LHL equal to, LHL for that we can consider f of x equal to x plus 1. So I'm writing here f of x equal to x plus 1. Like that, for RHL, I have to consider f of x equal to x squared minus 4. Then I am taking the value here for x equal to 1.9. Why I consider this 1.9 means the value should be very close to the number 2 and less than number 2. Again, it is very close to number 2 and less than number 2. So I have considered here 1.9. Like that, next value, iteration point is we can consider 1.99. Another value we can consider 1.999, which means very close to number 2 and less than 2. So if you put this value in the function, you will get 2.9 here, and if you put this value in the function, you will get 2.99. If you put this value, third value, in the function x plus 1, you will get 2.999. So we can conclude this table for LHL here. Again, we have to consider RHL value. RHL means here we have to consider the function f of x equal to x square minus 4. So I have considered here for x square minus 4, I have considered here the value for x is very close to actual value 2, but it is greater than 2. Again, it is very close to the actual value 2, but it should be greater than 2. So here I am considering 2.1. Next value I am considering here 2.01. Next point is I am considering here 2.001. If you look in this point column, so you will understand that is 2.1 and 2.01, 2.001, these are the values very close to the actual value 2, but it is greater than 2. So if you put this value in the function x square minus 4, the value will come like this, 0.41. If you put this 2.01 in the function x square minus 4, you will get 0.0401. If you put this 2.001 in the function, you will get 0.00040. So this is, I have iterated three values here. Then we can conclude like RHL here also. Then from the LHL column, if you look LHL column, this is the functional value comes like 2.9, 2.99, 2.999. It is very close to number 3. So we can evaluate the LHL equal to number 3. And the RHL column, if you are going to the functional value column, you will understand that is 0.41 and 0.040, 0.00040, something like that, which means it is close to 0. So RHL equal to 0 here. By using the table of functional value, we understand that is LHL is different from RHL. In this case, we can assume that is LHL not equal to RHL. This means, which implies function does not have limit, does